Good morning and welcome back to Quant Questions, where we go over questions commonly asked in a quant interview. Today's question is by Susquehanna and it's called St. Peterburgs Paradox. Jumping straight into our problem, suppose you're offered to play a game where you flip a fair coin until you obtain a heads for the first time. If the first heads occurs on the end flip, you are paid out 2 to the power of n dollars. What is the fair value of this game, and if the answer is infinite, enter -1. Alright, I'm going to give you guys 2 to 4 minutes to think up a solution to this problem. Remember, it's an easy problem on probability, so it shouldn't be too hard, but take your time and don't go straight to the solution. Starting with the solution, we need to first ask ourselves, what is a geometric distribution? Because it applies to this problem. A geometric distribution is used to measure the probability of getting the first success in the kth trial. We can derive this easily. It's the probability of the number of failures, 1 minus p to the power of x minus 1, times the probability of a success, which is just p. Now, we're counting the number of tails until the first heads. We can label getting a heads as a success with p equal to 0.5 and a tails as a failure. Therefore, the number of flips of a coin until the first heads follows a geometric 1/2 distribution, where p is equal to 1/2. Now, all we need to do is find the expected value of the payout of this game. Now we already get the probability that x is equal to x. We just need to sum over all values of x to get the expected payout multiplied by the probability that x is equal to x. Now we see exactly this. Instead we use n is equal to n, probability from 1 to infinity, which is the number of flips until a head, of 2 to the power of n, times the probability that n is equal to n. Simplifying this further, we get summation from 1 to infinity, 2 to the power of n, times 1/2 to the power of n, which is the probability n is equal to n. Now we just sum from 1 to infinity of 1, which is infinite. That means that the fair value of this game is infinite, and our solution is -1. So you see this yourselves, when you enter -1 into quantquestions.io, you get that's the correct answer. So remember guys, like, comment, subscribe. I'll see you all in the next video, and share this with a friend who might not get the solution correct.